Hello, I'm Sebastian. Welcome to 9 Trees podcast. Today, I will summarize and review the book. Black Holes, The Key to Understanding the Universe by Brian Cox, introduces one of modern physics' most captivating ideas and uses it as a gateway to the wider cosmos. Building on black holes as real astronomical objects rather than mere theory, the book frames them as natural laboratories where gravity, space, and time behave in extreme ways. Cox is known publicly as a physicist and communicator, and this work reflects that approach. It aims to make complex concepts approachable while preserving the sense of wonder that black holes inspire. Readers are guided through how black holes form, how scientists detect and measure them, and why they matter for understanding galaxies, cosmic history, and the limits of our current theories. Along the way, familiar pillars of 20th century physics appear, including relativity and quantum ideas, because black holes sit at their intersection. The result is a concise, curiosity-driven map of how studying the darkest objects in the sky can illuminate the structure and origin of the universe itself. I will give you key takeaways from this book. Firstly, black holes as real astrophysical objects. A central theme is the shift from black holes as a mathematical curiosity to black holes as observed inhabitants of the universe. The book typically orients readers around the basic conditions needed to create a black hole, such as the collapse of a massive star or the growth of supermassive black holes in galactic centers. From there, it clarifies what scientists mean by an event horizon and why the horizon is not a physical surface but a boundary in space-time that changes what information can reach an outside observer. A key practical emphasis is on how we know black holes exist without directly seeing them in visible light. The discussion tends to highlight indirect but powerful evidence: stars orbiting an unseen massive object, hot gas and accretion disks emitting X-rays, and the way black holes influence their surroundings. This topic also sets expectations about scale, separating stellar mass black holes from supermassive ones and showing how both fit into a broader cosmic inventory. By treating black holes as measurable, evolving objects, the book positions them as legitimate tools for understanding astronomy rather than exotic speculation. Secondly, relativity, space-time, and the meaning of the horizon, black holes provide a vivid route into Einsteinian gravity, and the book uses them to explain what it means for gravity to be geometry rather than a conventional force. Instead of focusing only on formulas, the narrative usually develops intuition, mass, and energy curve space-time, and objects follow paths shaped by that curvature. In the black hole setting, this leads to the striking idea that the event horizon is a point of no return defined by causal structure, not by material walls. The topic naturally expands into time dilation and gravitational redshift, showing how clocks near a compact object tick differently relative to faraway observers. It also addresses tidal forces and why approaching a black hole can mean extreme stretching depending on the black hole mass. Supermassive black holes can have gentler tidal gradients at the horizon than smaller ones, an unintuitive but important detail that helps readers separate cinematic myths from physics. By grounding these effects in space-time geometry, the book connects black holes to a broader understanding of orbits, light bending, and the way relativity shapes what we can observe throughout the universe. Thirdly, how black holes are found and studied. Another major topic is the toolkit of modern observation and inference. Since black holes do not emit light like stars, the book emphasizes methods that convert absence into evidence. One pillar is motion. Tracking how stars and gas move under gravity reveals hidden mass and can constrain size, letting astronomers argue that the mass must be packed into an extremely small region. Another pillar is accretion physics. When matter falls toward a black hole, it heats and radiates strongly, often outshining entire star fields in X-rays or radio wavelengths. This allows scientists to estimate spin and feeding rates and to study jets, which can transport energy far beyond the black hole neighborhood. The discussion may also include landmark achievements widely reported in public science, such as imaging a black hole shadow with global radio interferometry and detecting gravitational waves from merging black holes. Each technique highlights a different aspect of black hole behavior and strengthens the case that the objects are not just theoretical. The broader lesson is about scientific reasoning. Multiple independent measurements converge on the same conclusion, turning an invisible object into a richly characterized astrophysical system. Fourthly, black holes as engines of galaxy evolution. The book frames black holes not only as endpoints of stellar life, but also as active participants in shaping cosmic structure. In galactic centers, supermassive black holes can influence star formation and the distribution of gas through feedback. When they accrete matter, they can power active galactic nuclei and quasars, producing radiation and jets that heat or expel gas that would otherwise form new stars. This creates a self-regulating relationship between a galaxy and its central black hole, which helps explain why black hole mass correlates with properties of the host galaxy. The topic also clarifies that most supermassive black holes are quiet today, yet their past active phases may have played decisive roles in building galaxies over cosmic time. By connecting individual extreme objects to population-level patterns, the book uses black holes as a unifying thread in astrophysics. Readers come away seeing galaxies not as static islands of stars, but as dynamic ecosystems in which gravity, gas flows, and black hole activity interact. This perspective makes black holes relevant to the biggest questions of cosmic history: how structures formed, how they matured, and why the universe looks the way it does on the largest scales. Lastly, the frontier, quantum physics, information, and the limits of theory, a final important topic, is why black holes sit at the boundary of current understanding. Relativity describes gravity and spacetime with remarkable accuracy, while quantum physics governs the small-scale world. But black holes push both frameworks into the same arena. The book commonly introduces the idea that black holes have thermodynamic properties, including temperature, and that quantum effects imply they are not perfectly black but can slowly lose mass over time. This opens deeper puzzles about what happens to information associated with matter that falls in, and how a theory of quantum gravity might resolve apparent contradictions. Rather than presenting a settled answer, the narrative tends to emphasize black holes as test cases that reveal where existing theories strain. This topic also highlights the role of thought experiments and careful definitions in physics, because many black hole questions depend on what different observers can measure. The payoff for the reader is a sense of the living frontier. Black holes are not merely dramatic objects, but are central to the search for a deeper theory that unifies the known laws. Studying them becomes a way to understand both what we know and what we do not yet know. In conclusion, this book suits readers who are curious about space and want a coherent, modern picture of black holes without needing advanced mathematics. Science enthusiasts, students choosing between physics topics, and general readers who enjoy astronomy documentaries will find it especially accessible because it connects big ideas to observable evidence and clear physical intuition. The practical benefit is that it reorganizes how you think about gravity, time, and observation. Black holes become a framework for understanding why the universe behaves as it does, from the motion of stars to the growth of galaxies and the signals captured by modern instruments. That shift can deepen everyday scientific literacy, making news about gravitational waves, telescope images, or new missions easier to interpret and evaluate. Compared with many popular books on black holes, Cox tends to balance wonder with disciplined explanation, emphasizing how scientists know what they claim to know and why uncertainties remain. The black hole focus also keeps the narrative unified, avoiding a scattershot tour of unrelated space facts. If you want a single purchase that links cosmic spectacle to core physics and current research questions, this book offers strong value among similar introductions. If you would like to support Brian Cox, you can buy the book through the Amazon link I've provided in the podcast description. After reading the book, please let me know what you think and share your thoughts. See you around.